Number 1. The largest tunnel boring machine in the world suddenly stopped. It had gone only about 300 meters into a tunnel that is supposed to stretch almost 3 kilometers. China shocked the world with machines that seem to break the laws of physics. You arrive in China, roads, bridges, schools. You have never seen anything like it anywhere. They have bridges next to which the George Washington Bridge is just nonsense. And they are everywhere. These giant machines quietly, without unnecessary noise, deliver colossal projects faster, cheaper, and more efficiently than anyone could have imagined. Unnoticed by many, China has seized control of the global mega construction market. And today, a striking share of the largest construction projects on the planet relies specifically on Chinese technologies. What are these machines? How far can they go, pushing the boundaries of engineering possibilities? Join us, and you will see Chinese mega machines that stunned experts and changed the rules of the game. Enjoy the viewing, everyone. Tunnel boring machines that seem to break the laws of physics. Designed and built by Chinese engineers, China's tunnel boring machines perform brilliantly in the most difficult conditions. From soft soils beneath megacities to seismically dangerous zones, they dig faster, safer, and more precisely than previous generations of technology. Some of these machines are capable of producing up to 10 kilometers of tunnel per day at a cost of about $10 million per kilometer. This is only a small fraction of the roughly $50 million per kilometer spent on similar projects in the United States. One vivid example is a TBM from the company CRCHI, assembled in China and completing excavation of one of the 2 tunnel tubes of the Jianshan Eastern Road Highway under the Jiangnan River in the city of He, China. The diameter of the machine is 15 meters, making it one of the widest tunnel boring complexes in the world. Power is nearly 10,000 kilowatts. Torque exceeds 42,000, and the maximum tunneling speed is 50 millimeters per minute. All of this shows the scale and efficiency of Chinese engineering. Another giant is the TBM Caucasian. The tunneling diameter is about 15.08 meters, the length is 182 meters, the mass is 3,900 tons. This is one of the world's largest single-shield complexes for hard rock. Thanks to its enormous size, the machine quickly removes colossal volumes of soil, doing work in weeks instead of months, while ensuring stability and safety. Chinese TBMs use advanced slurry technology, which allows confident operation in soft soils and seismically dangerous areas. The system balances pressure in the excavation chamber and the surrounding ground, protecting the surface from subsidence and collapses, especially important in densely populated cities. Hydraulic jacks and articulated sections allow the machine to adapt to changing ground, and the slurry mixture dampens vibrations and protects the tunnel, even in areas where earthquakes are possible. These machines are the heart of China's most ambitious infrastructure projects. On the Ningbo-Zhoushan high-speed railway, the Jintang undersea tunnel is being built using a TBM with a diameter of 14.66 meters and a mass of 4,350 tons. This is the world's largest machine for an undersea tunnel on a high-speed line. In Guangzhou, a TBM with a diameter of 15.07 meters dug the Haizhu Bay Tunnel with minimal disruption to the bustling life of the megacity above. A clear example of how enormous power is combined with surgical precision. Every Chinese TBM is equipped with smart internals. Real-time systems track the torque of the cutting head, axial force, and ground pressure, automatically adjusting parameters for maximum efficiency and error minimization. Built-in geological mapping and a network of sensors allow the machine to feel changes in rock in advance, maintaining speed, safety, and tunnel geometry. Advanced complexes such as the independent Linghang project support intelligent tunneling, remote control, safety monitoring of the tail section, and automatic corrections under difficult geological conditions. A hospital in 10 days, a response to COVID-19. During the COVID-19 outbreak, China built the Hoshinshan Hospital in Wuhan in just 10 days. a huge medical complex with 1,000 beds. Construction began on the 23rd of January 2020, and already on the 2nd of February 2020, the hospital received its first patients at the peak of an unprecedented epidemic. As in the case of Mini Sky City, modular construction was used here. While site preparation was underway, ward blocks, corridors, and service rooms were assembled simultaneously at factories. This parallel process saved precious time and at the same time kept quality under control. Modules were made in stable conditions, which reduced the number of errors and delays on site. Speed was ensured not only by technology, but also by a giant army of people. More than 7,000 workers, engineers, electricians, and volunteers worked in around-the-clock shifts. Cranes, trucks, and special equipment hardly stopped. Clear coordination between the state, contractors, and suppliers ensured uninterrupted logistics. Chinese industry and supply chains delivered materials, people, and equipment without disruptions. These record projects became possible thanks to an entire fleet of ultra-modern construction machines, engineering monsters that literally rewrote the rules of the industry. Next, even more powerful. Kunlun, a transport and erection giant for 1,000-ton beams. Kun, named after one of the longest mountain ranges in Asia, is a unique machine of China Railway Construction Corporation Limited, designed for lifting and installing huge box beams in the most difficult sections, from mountains to rivers. Kunlun is the world's first transport and erection machine that can work with a 1,000-ton beam, performing the work of 3 traditional machines at once, while confidently moving on slopes of up to 30 degrees and on curves with a small radius. It can install beams with lengths of 24, 32, and 40 meters, which makes it possible to build bridges for high-speed lines with unprecedented speed and in very complex terrain. For all its power, Kunlun is lighter than many outdated analogs, yet stronger. It is assembled from high-strength steel plates used in aviation and submarines. This ensures both durability and maneuverability. In June 2020, Kunlun completed final heavy tests and soon installed the first 1,000-ton, 40-meter box beam on the bridge of the Fuzhou-Xiamen high-speed railway. This nearly 15-kilometer sea crossing bridge was completed in September 2023, which is astonishingly fast if we remember that building the 3-kilometer Golden Gate Bridge took about 4 years. The ability to work with such enormous beams reduces vibrations from passing trains and increases stability at high speeds, helping China move into an era of trains traveling at 400 kilometers per hour. Kunlun is equipped with advanced intelligent systems, a laser matrix for autonomous navigation in tunnels, real-time monitoring of beam position, automated transport and installation, precise integration with the railway control and maintenance system. Operators see the condition of beams and the machine in real time, which increases both safety and speed. Innovations make it possible to reduce construction costs by about 20% and speed up installation by 25%, while the machine needs less space than traditional beam installers. Kunlun has already shown its versatility. On the Zhongzhou-Chongqing high-speed railway section, where more than 90% of the route within Chongqing consists of bridges and tunnels, the machine worked on steep slopes and sharp turns, demonstrating capabilities far surpassing old technologies. This machine does not just break records, it turns the incredible into routine work. And next, even higher and heavier. Bona, a wall climbing machine for skyscrapers. Bona is a giant self-propelled platform that climbs high-rise buildings, radically accelerating the construction of tall buildings. Its height is more than 40 meters. Its mass is about 2,000 tons. With its help, a new floor can be built in about 4 days, 20% faster than with classic methods. Unlike traditional tower cranes, Bona does not need external scaffolding. Its reinforced steel frame combined with hydraulics and automation allows it to lift and install large panels beams, and slabs, while maintaining high stability. A sensor system continuously tracks loads, tilt, and weight distribution, protecting the structure from errors even at extreme heights. One of Bona's most impressive functions is the ability to rise together with the growing building. After completing the next floor, the machine climbs higher without being disassembled and reassembled. Hydraulic jacks and counterweights ensure stability during ascent, and automatic systems compensate for wind, structural movement, and load shifts. Thanks to this, Bona can work continuously, lifting, aligning, and installing elements with high precision. The machine can perform several tasks at the same time: lifting, positioning, and installing elements. At the same time, it reduces the number of workers who need to be at dangerous heights. From the standpoint of safety and speed, this is a qualitatively new level of high-rise construction. And most importantly, these mega machines are not locked in China. They can be transferred to any point on the planet. And for this, a special maritime giant was created. Kunlun. 2. A heavy semi-submersible ship for mega cargo. This is a semi-submersible heavy-lift vessel, specially created for transporting oversized and project cargo. 10-megawatt offshore wind turbines and their components, giant structures and construction equipment. The vessel is designed to be maximally versatile. It can perform a wide range of tasks in marine construction and logistics, from transporting sand and crushed stone to delivering to offshore platforms, oversized and awkwardly shaped cargo. The open deck is optimized for heavy and unusually shaped objects, which allows efficient work both near the coast and in the open sea. The length of the vessel is about 115 meters. The width is 26 meters. The draft is up to 6.6 meters. A deck area of about 2,000 square meters can withstand up to 6,000 tons of cargo, and the reinforced structure allows safe transport of vehicles and special equipment, including 60-ton trucks. The superstructure is located closer to the bow to free up maximum deck space at the stern for loading and unloading heavy objects. The vessel can hold position even with winds up to 6 points on the Beaufort scale, often working without the help of tugboats and increasing operational efficiency. An intelligent energy management system monitors movement, mechanism operation, and navigation in real time, optimizing power distribution and fuel consumption. A predictive maintenance system detects potential problems early, so repairs can be made before serious failures. Together with the modular deck and flexible fastening system, this makes operations safe, efficient, and more environmentally friendly. All of its solutions make the vessel an ideal platform for complex offshore construction and long-distance transport of heavy equipment. Total global domination. In the early 2000s, China had no share at all in the tunnel boring machine market, TBM. Western companies had been developing this technology for more than 150 years, and it was believed that this was too narrow and complex a field for late newcomers. But by 2024, the picture began to look like an alternate reality. China dominates the market, supplying machines for virtually all major projects worldwide. While California for 16 years and for billions of dollars tried to build a single high-speed rail segment, China in the same time laid more than 40,000 kilometers of track, with tunnels, bridges, and viaducts connecting megacities like parts of a huge Lego set. China has turned speed itself into a strategic weapon. What in other countries seems almost impossible, there has become routine. So, how do you pack a century and a half of progress into 2 decades? Chinese engineers call it this: concentrate all the forces of the country on big tasks. Instead of scattering research among separate companies and universities, China lined up the state, industrial giants, and the workforce into one line, under a single goal. Machines were bought abroad, disassembled down to the last screw, copied, redesigned, and launched into mass production, almost like the military. This was not evolution, but acceleration. Where the West moved in small steps through competition and long, tried, failed, remade cycles, China removed delays and hit fast forward. A gap of almost a century was closed in less than a quarter of that time. And this is not an accident. China created such a steep learning curve that the West physically cannot keep up with this pace. Behind this leap is a real army of engineers. 6.7 million students, trained in a semi-military regime and directed straight to the construction of the country. Machines can move mountains, but without people, they are just metal. And here, China has the main advantage. While the West argues about work-life balance, China has built the largest engineering education system in the world. Millions of students study in more than 23,000 courses. This is not just a number, it is a workforce the size of a country, trained, disciplined, and directed into infrastructure and innovation. Every year, China graduates 1.5 million engineers, 1/3 of all the engineers in the world. The United States graduates less than 1/4 of that number. So when critics ask how China can build 10 high-speed rail lines while the West struggles to pull even one, the answer is simple. There are people there to actually build all of this. In the West, construction sites stop on weekends, holidays, during storms and heat. In China, construction is a campaign. Teams work in 3 shifts without stopping, 24/7, in any weather. The machine does not sleep, and its operators do not either. Imagine, a giant machine bites into a mountain at midnight. One shift finishes, another takes over control, a third prepares to enter the work. This is not chaos, but rehearsed choreography, from the classroom to the construction site. Engineers are taught to treat impossible as a challenge, not a stop sign. The result is right before your eyes. By the end of 2024, China had 3.5 million active invention patents, and more than half were already used in industry. In many Western countries, patents lie as dead weight. In China, they are ammunition of progress. This scale and discipline change everything. Before you is no longer just a workforce, it is a force of nature, and it is not only about quantity, but also about direction. Millions of minds are directed at mega projects, AI, energy, and machines that turn impossible into the norm. Where the United States can spend a decade developing and approving a single new TBM, China in that time releases several generations of machines, improving each next one and lowering the cost through scale. Look at the chronology. In 2008, when Beijing was preparing for the Olympics, China was still dependent on foreign TBMs. Already in 2011, just 3 years later, the first domestic machine rolled off the line. By 2017, Chinese TBMs were already exported to more than 30 countries. Today, 7 out of 10 tunnel-boring machines that cut the Earth's crust worldwide bear the marking "Made in China." And as if dominance in underground tunnels were not enough, China created a machine unlike anything the world had seen before. Iron Monster, SLJ 932, bridge after bridge SLJ 932, known in China as the Iron Monster, is one of the most powerful bridge-building machines on the planet. It was created by Beijing Wow Joint Machinery, based on a design by the Shijiazhuang Railway Design Institute. Its dimensions are impressive: length about 91 meters, width 7 meters, height about 9 meters. Mass is 580 tons, meaning heavier than some warships. This is one of the longest land-based self-propelled mechanisms ever built. Unlike obichny cranes, which can lift only small elements and require a lot of space to operate, the Iron Monster handles entire bridge spans, with the mass of each up to 950 tons. It lifts a giant concrete beam directly under itself, drives to the edge, hooks onto the support, extends forward and carefully lays the span into place. Then it moves on and repeats the cycle, span after span, until the bridge crosses the gap. its mobility is no less impressive. The machine travels on 64 wheels, grouped by 4. Each group can rotate 90 degrees, so the monster can move sideways, sliding and placing beams exactly where needed. Despite its size, the machine moves confidently, up to 8 kilometers per hour empty and about 5 kilometers per hour with a load. Over its lifetime, one such unit can lay from 700 to 1,000 bridge spans. From the outside, it may resemble a giant transporter, but it has one clear task: to build high-speed railway bridges where the route crosses deep valleys and wide gorges. Combining lifting, transport, and installation, the Iron Monster removes the need to build temporary scaffolding and lift parts with dozens of small cranes. The schema is simple but revolutionary. The machine approaches a support, lifts a prefabricated beam, extends to the next support, locks in place and lays the span. Then, it moves over the newly laid section, and again. Beam by beam, they connect through expansion joints, forming a strong bridge that is built much faster than classic technologies. The advantages are enormous. Fewer workers, fewer separate parts, many times higher speed. Safety is a separate topic. Each machine is Rashitna for a load that exceeds the weight of any train that will ever run on these bridges. Crews undergo special training, learning to work at great heights and in difficult conditions, operating the machine with almost military precision. What used to take decades is now done in a few years. Iron Monsters helped China deploy a high-speed network with a total length of more than 30,000 kilometers. No country builds bridges at such rates. Once Western engineers said that such a machine, in principle, should not work. But it does, without respite, efficiently, and at a scale against which traditional cranes look like technology from the last century. And yet, the next hero can outdo even more. Miracle of 19 days. A skyscraper in 3 weeks. The Mini Sky City project in the city of Changsha, Hunan Province, became one of the most striking examples of ultra-fast construction. In 2015, Broad Sustainable Building, BSB, assembled a 50-story skyscraper in just 19 days, on average 3 floors per day. Such speed became possible thanks to innovative technology and precise organization of work. BSB used modular construction. Most of the structures were produced at the factory and then delivered as ready-made modules to the site. Each block was designed in advance, so that on-site, everything could be assembled like a construction set, quickly and without adjustment. A total of 2,736 modules were manufactured, each with maximum precision so they could be joined without gaps or distortions. This approach did not just speed up construction, it improved quality, reduced waste, and decreased the environmental load compared to traditional methods. The project was planned down to the smallest detail. Every step was scheduled and synchronized. To build a high-rise in less than 3 weeks means setting a new global standard of speed. No wonder the entire construction world paid attention to this skyscraper. But China's records did not end there. XCMG XGC 88,000, a crawler crane that lifts the impossible. On paper, it looks like science fiction. A crane capable of lifting 4,000 tons, with a boom reach up to 144 meters, and its own mass of more than 5,300 tons. So you understand the scale. This crane can easily lift a fully loaded Airbus A380. This is an ultra-heavy crawler crane from XCMG. Since 2013, when it went into series production, it became the world's largest mobile crawler crane, surpassing the famous Liebherr LR 13,000. In addition, it is one of the largest self-propelled land machines, even compared with NASA's legendary transporters. The crane consists of 2 main parts. The first is the machine itself. Maximum boom length is 144 meters. Total length, including the counterweight radius, is 173 meters. Height is about 108 meters. Lifting capacity is from 3,000 to 4,000 tons. In practice, it has already lifted up to 4,500 tons, creating a moment of up to 88,000 ton-meters. 3 Cummins engines of 641 kilowatts together deliver nearly 2,000 kilowatts of power, more than 2,500 horsepower, ensuring movement, assembly, and disassembly, as well as backup power. The operator's cab looks like a small office, air conditioning, a comfortable chair, and even a sofa for 3. The second part is the crawler module with counterweight. Height is 9.7 meters, length 29 meters, mass about 2,900 tons. It has its own control cabin and a working radius of almost 29 meters. Together, the crane weighs almost 5,400 tons. Watching it work is like watching gravity slightly give up ground. This is a level Western technology could not reach for a long time, but even this giant is only part of China's engineering arsenal. The next hero turns a seemingly ordinary task, concrete pumping, into a national record. Pump King, the king of concrete delivery. When they built the Shanghai Tower, builders needed to raise concrete almost 2/3 of a kilometer up vertically. Most pumps in the West would have given up after just a few hundred meters. A Chinese Sany pump with an 86-meter boom broke the world record, pumping concrete to a height of about 621 meters, higher than the height of the Eiffel Tower. It worked so flawlessly that it earned the nickname Pump King, the king of pumps. As of 2024, it holds a Guinness record as the world's longest concrete boom truck, thanks to thoughtful design, innovative materials, and precision engineering solutions. It completely changed the understanding of how super tall buildings can be built. The pump boom consists of 7 sections, more than standard 5 or 6 section booms. Thanks to this, the operator can reach the most hard-to-access places in dense urban development or complex terrain. The work of Pump King impresses no less than its size. The automatic boom control system allows, with one press, to unfold it, switch to vertical or horizontal delivery, lock it, and limit the working zone. Stabilization reduces boom sway by 50% and reduces the oscillation amplitude of the rotating tower by 60%, increasing accuracy and safety. Energy-saving technologies increase operating efficiency by about 25% and reduce fuel consumption by about 10%. The self-diagnostic system can detect more than 150 types of malfunctions, so operators can quickly find and ustranate problems without stopping construction for long. Pump King has already left a mark on global high-rise construction. At the same Shanghai Tower, it lifted ultra-high-strength concrete to a height of more than 620 meters. At that time, it was a world record. Wear resistance is another strong trump card. The pump pistons withstand pumping 25,000 to 30,000 cubic meters of concrete before replacement. Many parts are made from special materials resistant to friction and Uter loads. But China did not limit itself to skyscrapers only. Its ambitions stretch along thousands of kilometers of rails. CYP 500, a machine that lays rails for kilometers a day. The Chinese track-laying machine, CYP 500, can lay up to 2 kilometers of track per day. It works continuously, 24 hours, turning railway construction into a continuous high-productivity conveyor. In March 2020, CYP 500 went to its first construction site in Southeast Asia, on the China-Laos Railway. There, it laid a 500-meter steel track in Vientiane, becoming the first section of the route and the longest steel rail link outside China in Asia. The machine worked flawlessly, easily exceeding the plan of 1.5 kilometers per day. CYP 500 was created for large projects with high loads. It combines rail laying, leveling, and precise positioning in one automated cycle. Continuous operation reduces downtime, and high-precision control systems ensure laying with accuracy down to millimeters. The machine handles complex terrain, sharp turns, long bridges and tunnels, maintaining pace even in the hardest sections. In just 4 years, CYP 500 technology increased China's track lane capabilities from 500 meters to 2 kilometers per day, setting a new standard of efficiency. But to grow upward, China needed even more unusual machines. And this is only part of the stories about how Chinese mega machines are changing our world, from the depths underground to the tallest skyscrapers and windy seas. Right now, I recommend watching the previous episodes that have already appeared on your screen. Thank you for watching on the Top Facts channel.